Hello, everyone. So today we are going to understand what is. Okay, everyone. Till now we have seen how deep learning works by using input process output. Now let's understand how TensorFlow and Keras work accordingly. And it's a beginner friendly overview so that I'm going to keep it easy for you as you are going to get started with it. So let's understand what is TensorFlow. TensorFlow is one of the most in-demand tool used by ML or AI engineers. It is an open source provided by Google and it is used to build various machine learning and deep learning models. Whether you talk about image classification or you talk about image recognition, face recognition, all these, or even language or text recognition, all these things are being done by TensorFlow. So if you are going to see, it is used to build various machine learning models as well as TensorFlow helps to train and execute neural networks. So when we talk about neural networks, what exactly? So in the previous class, we have understood what neural networks are and how it works, such as image recognition, natural language processing, digit classification, and much more by using same model that are used for development of TensorFlow as well as TensorFlow facilitate the estimation of output at various scales. The main objective of using TensorFlow is not just the development of any neural network or deep learning. It is all about to reduce the complexity of implementing computational on large numerical data. As we know, when we are dealing with data and we wanted to run neural network inside it, or we wanted to create on the basis of that, then a library which you are going to use, that is TensorFlow. Let's understand more about it. Over here, we are going to see, as we have discussed, it's an open source provided by, with which you are going to run your machine learning models, and it is developed by Google. What you are going to do with it, it allows you to build and train machine learning models and deep learning models by using deep learning, computer vision, NLP, and much more. Why TensorFlow? Now let's understand what we have discussed. Now it's the time to understand why it is important. It is scalable across CPUs and GPUs and TPUs. Large community and extensive documentation is there for TensorFlow. It supports deployment to web, mobile, and edge devices. It means as a user, you can use it from anywhere and everywhere. Basically, it helps and you can run it on the top of with the help of Keras also. Keras are high level API for building and training neural networks. So together, when we are going to combine TensorFlow and Keras, you will be able to find a modular as well as you will be able to convert your complexity into a user friendly outcome. So that is why we will be using, and we are going to do that hands-on also. TensorFlow is full-fledged ML framework, whereas Keras high-level APIs that simplify TensorFlow usage. Keras is also nowadays a part of TensorFlow, that is tf.keras, and that is what we will be using in hands-on. So let's understand how the workflow is going to be when we are going to put our hands-on practice on it. We are first of all going to load and prepare the data. Second, we are going to define the model architecture, that what you are going to do, how you are going to process, the classification are going to happen in that. You are going to compile the model loss function and optimizer along with matrices. As in the previous class, we have discussed that Adam is an optimizer which you are going to use everywhere, and that is the simplest one. Furthermore, you are going to train the model, and at the end, you are going to evaluate and predict. All these 5 steps, which we usually follow when we are creating our machine learning model, similar way you are going to do over here as well. Let's understand the use cases of TensorFlow, image and speech recognition, as I have already shared with you. You can do text classification and sentiment analysis also, predictive analysis and recommendation systems. robotics, and autonomous system. So understanding all these concepts, now quickly, we are going to write a 20 to 30 lines code and we are going to see how TensorFlow with Keras work. And with that, we are not going to upload any data set. We are going to create the data set using NumPy inside it also. So the first step which you are going to do while you will be getting started with it, you are going to pip install TensorFlow. I'm going to share the steps with you. So let's quickly get started. Going to do, first of all, we are going to open our command prompt. So you are going to go to your start search command prompt, and here what you are going to do, you are going to say pip install TensorFlow. I have already installed it. So let's see how it is going to say. When you are going to install, it is going to uninstall NumPy because inside TensorFlow, you'll get NumPy. So let's quickly do that. So over here, you can see that using cache, TensorFlow is already there. So I'm going to use it, how it is going to say that installing collected packages of TensorFlow. So once it is installed, so what you are going to do, the next step, you will be using it. Could not install packages due to some error. No search file library is there. It's already pre-installed. The new release of pip is already available. So I have already installed it. So what you are going to do, you are going to install it at your end. So as of now, I'm going to close it and I'm going to open Google Colab. So let's quickly open Google Colab. All right, everyone. So I have already signed into my Google Colab. You are also going to do the same. So what you needed to do, you are going to just type Google Colab. And once you will be entering, it is going to ask you to either create an account or you are going to sign in using your Google account or Gmail ID. Once you have signed in, it is going to land you onto this particular page. From here, you are going to click on File and you are going to click on New Notebook in Drive. Once you will be opening this notebook, it is going to open a Jupyter notebook in front of you. And from here, we are going to get started. So the first step which you, and today we are going to write a very simple 30 lines code. So first of all, you are going to write import TensorFlow as TF, right? And the second one which you are going to write import NumPy as NP. So this is what we will be using. This is going to be our step number 1. So I'm going to write step number 1. All right. So I'm going to put hash step 1 and step number 1 is import libraries. So that I'm going to explain each and every part among all of you. Now we will be writing, that is our step number 2. Step 2 is going to be print TensorFlow version. If you want that, if you don't want, you can skip this step also. Basically, I'm going to skip it. I'm directly going to move to step number 3 and consider it as step number 2. And that will be build a simple sequential model. All right. And for that, what you are going to do, model is equals to tf.keras dot sequential. Sequential, and I'm going to create the sequence over here. tf dot keras dot layer layers dot dense dense, and that is going to be 64, where activation function which I'll be using, activation is equals to reloop, that input, and the input value over here which I'm going to shape is equals to 10. And then I'm going to 10. Reloop done. 10, and I'm going to close it. Yeah. Now, once you are done with that, this is going to be your input value. Now, how hidden layers are going to work, that is what you will be doing. tf dot keras dot layers dot dense, and that is going to be 32. Activation, and activation you are going to keep same, that is going to be ReLU, and you are going to just put, this is going to be your hidden tf dot keras dot layers, and that is dot dense, and that will be 1. Yeah. Once you are done with that, over here at the end, it's already closed. Now you can see over here, it's closed. So I see there is one such error which I can see over here. That's okay. I'm going to move to the next one. Step 3, that is going to be compile the model. And in compilation model, model dot compile, and we will be starting optimizer is equals to Adam. So here we will be using Adam. I had already explained where you are going to use Adam, where you are going to use ReLU, right? Loss function is equals to mean squared error. And then you are going to put matrices is equals to MEMA, mean absolute error, and then you are going to close it. Here I can see that there is some error which I needed to find. 64 activation ReLU input shape 10. Okay, after 10 also I needed to do this and this. All right, so this is going to be the hidden layer. This was the mistake, and now it's done. So this part is done. Now what we are going to do, absolute error we have done. Now we are going to reach to the next step of our, that will be step 4. And step 4 is going to be generate dummy training data. So this is going to be a training data sample, 100 sample data we will be creating. And in that, we are going to define the same thing. X train is equals to np dot random dot rand 110. That means 100 rows, 10 columns, and y train, okay, y train is equals to np dot random dot rand is round off 101. So that is the data which we have created. Now step number 5 is train the model for 5 POCHS. And here we are going to put model, the same thing, model dot fit for training. We are going to follow the same step the way we have done previously. X train, Y train, EPO CHS is equals to 5 Then we are going to put a batch over here. Batch size is equals to 10. Now, once we are done with that, we'll be moving to the next one, that is step hash step 6. And step 6 is generate new data and prediction. Here, what we are going to do, because I wanted to give you a complete exposure, how you are going to create the data in Excel by putting rows and columns. Now we are creating data itself by using NumPy inside the code itself, by using code. So let's quickly get started with that. So what we have created by using over here NumPy, we have created the training data. And now we are going to run the prediction. So X test is equals to np dot random dot rand 5 to 10. The next one which you are going to do, that is prediction, is equals to model dot predict, and that will be X test. Right? We used to do that prediction like model dot y predict and X test. So now it reached to step 7. That is going to be our output predictions. Print /n, and over here what you are going to do, /n, we are going to write predictions on the new data, and let's see how it is going to go ahead. And over here we are going to write print predictions. Now let's see. Now let's run it and see how it is going to go. Over here you can see that it is not more than 30 lines. So that is what we will see, and let's run it. So what we are going to do, we are going to run all. It is running. It takes some time, but it is going to run and it is going to give you an output. This output is basically going to tell you how TensorFlow and Keras work. So build a simple sequential model of Keras. So I have, like, there is one error in it. Okay. All right. So in the first one, I made this error. Okay. This is going to be capital sequential. Yeah. I'm going to delete this particular part. Yes, now it's fine. Sequential, then slash. Now it's done. Now let's me run all again. Okay, and this also, let me see if there is an error. Keras, layers. Okay, dense is going to be capital. My done. Again, X train, Y train. So here also I think I have made a mistake in capitalization only, model dot fit. X train, Y train, box. Okay, batch size. That is what I made a mistake. Batch is going to be in small. While you are writing, you needed to take care of this particular segment. Now you can see the predictions on the new data is 53, 35, 48, 36, and 49%. This is how you are going to run. So randomly, when we are taking any data, these are the predictions which you are going to get. So with each of that, you can see that it has this is mean square absolute error. And here is the loss, which is loss function. So this is what you are going to get. And this is how you are going to run the predictions using TensorFlow and Keras. It's a very, very simple code. It is what you are going to do. And later, okay, everyone, let's understand what we have done in this particular code. I know that this code is new among all of you because you must be using activation function and TensorFlow library for the very first time. So I'm here by explaining each and every step in detail. Step number one says import libraries, import TensorFlow as TF and import NumPy as NP. Therefore, the first thing first, we need to bring in tools which we are going to use. TensorFlow helps us to build and train neural networks, whereas NumPy helps us to work with numbers and create training data. And that's why we have used step number one. Thereafter, when we are going to talk about step number two is build a simple sequential model. Here you must be looking on to this sequential, right? This sequential is actually like we are now designing the model. We are using sequential, which means layers are stacked one another, like one after another, where I have distributed the data into input, hidden, and outer. Wherever the first layer, which is of 64 neurons, the 64 is actually the number of neurons, uses ReLU, which is ReLU activation, and takes 10 input features from it. Thereafter, the second layer, which contains 32 neurons, also using ReLU, which is considered as your hidden layer. And thereafter, the final layer, which is your outer layer, just use only one neuron. And this neuron is going to give you the output. This is like, for example, imagine water flowing through pipes. Each layer processes the information and pass it on from the pipe. So this is what it explains in that manner. Now let's move to the next step, which is your compiling the model. For compiling the model, understand optimizers. Here we have used compile model.compile, which is to compile that model. We have created that function. Inside that function, we have kept optimizer as Adam. Now, this is the brain behind the learning. It updates the weight to reduce the error. This is the work of an optimizer. Whereas the loss function, which is mean squared error, this measures how far off our predictions are. And then later we have matrices. This shows us the mean square error after training, which we have utilized in the previous classes also. I hope you understood this particular segment. Now let's move to step number four. Step number four is all about how you are going to generate a dummy training model. To generate a dummy training model, now we are going to use XTrain, where 100 rows of data and each row contains 10 features that is being considered as input. Wherever Y train, which we have taken, that is 100 corresponding output values we have kept inside it. Even though this data is random, it perfects for practicing. And today, why I have kept this data over here, because previously we have used a data set We created the data set on CSV. Now is the time to create a data set using random or NP, which is NumPy. So that's why I wanted to give you a greater exposure how you are going to create and work with different sets of data, which includes creating the data, which includes fetching the data, which includes create by code. So this is what we are doing. Now let's move to our step number 5, and that is training the data. When you come to training the data, let me quickly move little down. Here is step number 5. Step number 5, I hope you remember, which is model fit, where machine says, now I am ready to get started with all the models, right? I have learned everything. The same thing, but here we have used epochs. Now, what is this? It looks at the full data 5 times. Epochs means it is going to run that 5 times to give you the accuracy. And batch size 10, it learns from 10 samples at a time. So if it is running 5 times 10 at a time, it is learning, right? So this is what we are here, 5 or 10 random data, and this is how the prediction is being calculated. And thereafter, the last one which we have kept, that is prediction. So in the prediction, how it is being done, X test is new data. It has not seen before by the machine. It was not trained on that. So this was the set of data which was taken from the entire data for the testing part. And predict, the model tries to guess the output which was being tested. The way we have done in the income prediction part. Now, and finally, let's print what our model predicts. And over here at the end, you are going to find this is our 5 Apocht's result after running it all the time. And these are all loss function. 5 times it has run in a row with MEA. So here is the result. I hope you have understood it. Therefore, would like to just reiterate the entire part what we have learned in today's session. In today's session, we have understood what is TensorFlow, how to use TensorFlow, why there is a need of TensorFlow. So all 5s and 1H we have understood using TensorFlow and Keras. Keras are being used with TensorFlow to provide greater exposure by creating predictions, whether it is image recognition or any of the models, prediction models, which you would like to create. Now, with that, we have understood what are activation functions. We have understood what are loss functions and how it is being calculated. Thereafter, we have understood that machine learning, deep learning, artificial intelligence, and neural network. What is the correlation among all these? So, neural network is part of deep learning. Deep learning is part of machine learning, and machine learning is actually a subset of artificial intelligence. And artificial intelligence is basically when human mimic, or you can say when a machine mimics human behavior, and that is being created artificially by using analogies, algorithms, and patterns using machine learning formulas. So, this is what we have done in today's session, uh, putting into a greater exposure of it, what machine learning does for all of you. Machine learning provides, you can say, a help among all us. It provides face recognition. It provides whether you are wearing mask or not. So you can create so many models out of it. Now is the time for you to explore more. Now you can fetch the data. So try using it, right? Now, the second is you can try and create, change the value and try and run the same algorithm, same formula for a different data set. Just change the values little bit. Instead of 100 over here, you can put 520. Over here, you can put 205. So it is completely up to you. And this then run the same model and see the result. Find your own analogies. And I'm sure that you are going to learn from your own experiments. So this was all about today's session. Today's session was completely catering to how neural network works, what is the role of TensorFlow and Keras in that, and we have done a hands-on practice using Python and TensorFlow library. I hope you have enjoyed the session. Stay tuned. In the next session, we are going to see how without using any code, you are going to create a prediction model using Azure Machine Learning Studio. So stay tuned in this session and I'm going to see you in the next class. Thank you everyone and have a wonderful day.